It's simple mathematics. Check it out. I revolve around science. What are we talking about here? I'm going to review concepts in our patterning unit from start to finish. So you can see here I have a pattern of red blocks and blue blocks, and it's building as we move between consecutive pictures or consecutive terms or consecutive figure numbers. So I'm going to go ahead and build the next picture in the sequence. Okay, you can see that the picture is growing in each term. And if we look at how it's building, then we can find the pattern rule. All right, so when we move, we notice that we have 4 red blocks and 2 blue blocks for a total of 6 blocks. And then we have that original 6 blocks plus 4 blocks for 10 blocks. And then we have the 10 blocks plus 4 blocks for 14 blocks. And then we have the 14 blocks plus the 4 red blocks for 18 blocks in total. All right, so we can compare these values and look for a pattern rule between the values. So if we reorganize our thinking of the number of blocks into a numerical pattern, we end up with a pattern that goes 6, 10, 14, 18. Okay? We notice that, or you should notice, that the difference between each term ends up being a value of 4. And it's the same difference in each term as we move along. So the difference between 6 and 10 is 4. The difference between 10 and 14 is 4. The difference between 14 and 18 is 4. So we can see that we are adding 4 for each term. Now, if we put this into a table of values, noticing that we have a t-chart, all right, and we have our term number here, and we have our term value here. We can input this same data. So we have our term 1 here, and it has a value of 6 blocks in total. And then our second term, it has a value of 10 blocks. And then our third term has a value of 14 blocks. And then we have our fourth term has a value of 18 blocks. Okay? Now, we're looking for the connection between the term number and the value that it holds, because then we can make some predictions about future. If we know the connection of how we get from the term number to the term value, then we can figure out any term in the sequence. Okay, and that's our goal. So if we look at our table, we can see that we have a difference of 4 blocks for each term. Now, this pattern continues past the 18th value, or the 4th term, which means that it also can start before the 6th term. Okay? Now, this is what we referred to in class as the 0 term. Okay? And it gives us a vital piece of information. So if we look at if we look at the difference or where the pattern must have come from prior to the first term, then we can see that it must have started at 2. So if we include this information in our table of values, we get a key piece to the puzzle. Okay, now, where would that 2 come from in the picture? Well, we can see that if we looked at the picture before the first term, it would actually have started. We notice that all pictures have to have these 2 blue blocks. So we end up with this value of 2 at the 0 term. Okay? Now, the goal of this is to build towards the algebraic expression. An algebraic expression is built up of a coefficient applied to the variable. So the variable or applied to the term number. So here is our term number. All right, we've got our term number 0, 1, 2, 3, and we have to look at how the term number changes in each picture. Well, it changes by 4, an increase of 4 blocks in each picture. So we have 4 plus 4 plus 4 plus 4 in each picture. So for each term, we don't have any 4s for the first term, but then after this one, we have 4. And then for the next one, we have 4 plus 4. All right, and then the next one, we have 4 plus 4 plus 4. And then we have 4 plus 4 plus 4. But we also have to include this first 2 green blocks. So in each one of these cases, we'd end up with the plus 2 green blocks, plus 2 green blocks, plus 2 green blocks, plus 2 green blocks. All right, and if we look at that, we'd end up with a value of, first off, 4 plus 2 gives us 6. 4 plus 4, 8 plus 2, 10. 4 plus 4 plus 4 plus 2 gives us 14. 4 plus 4, sorry, I missed a 4 there. So 4 plus 4 plus 4 plus 4 gives us a value of 18. So you can kind of see that we have an increase of the groups of 4 in each term as we go along. And you can kind of notice, hopefully, that the number of groups of 4 relates directly to the term number. So really, that is how we are moving between each term. And we can figure out any term in the sequence. All right? So we just put a spaceholder for any term. We call this the variable. Okay? It relates directly to the term number. Okay? But it's a placeholder for any term in this sequence if we were to continue on down. All right? So we can continue this pattern all the way down. But really what we can do is use a placeholder represent that term number. So in this case, we have a coefficient. All right, we have the coefficient here is 4, and that special 0 term, this gives us the constant. Okay, or we can think of the constant of where our pattern actually starts. Okay, we see that it starts at 2 in there on the list, starts at 2 blocks, and starts at 2. All right, if we have no term number, we still have a value of 2. Okay, so if we put all of these pieces together, we have the coefficient of 4 applied to any term number, and we're going to use n to represent any term number. All right. Now, why is it 4n? Well, this means 4 times n. All right, or n groups of 4, or any groups of 4. And we can solve for any number of groups of 4, all right, using the variable. Then we still need to make sure that we include the original 2 blue blocks, and that's where the constant comes from. So we have the constant, which is the start, not the first term, but the start of our pattern. Okay? And then we have our coefficient, okay? Coefficient, which is the change in each term. And then we have simply our term number, which is the variable. Okay? Now, as we go along in our mathematical career, this term number, this n, will become variable. Okay? It means it might change. Okay? Now, where we go from here is we can solve any number of questions based on this pattern rule. So, if we wanted to find let's say we wanted to find the 17th picture. How many blocks are in the 17th picture? Well, we can use this expression. Rather than continue our table values all the way down to 17, we can use this expression to solve for the 17th picture. Okay? So, we use the coefficient of 4 times the picture number plus our starting point or constant value of 2, and we can solve for this. So we use a format called essay, and in previous videos I have that, okay, to show you how to do that. So we're going to solve for the 17th. So E stands for expression, which we've written. Then we need to substitute in or plug in. All right, so we're going to take out the n and put in the 17. So we end up with 4. Now, we're going to use brackets because we don't want to make a mistake and make this 417. So we're going to end up with 17 in brackets plus 2. Now, we know that, and we've learned that, a number beside a bracket or beside a symbol automatically means multiplication. So this is 4 times 17. Now, if you have a calculator, maybe you can plug it in with a calculator. But if we think about it, 4 times 17 is like 4 times 10 plus 4 times 7. So this gives us 40 plus 28, which gives us 68. All right, so therefore, 4 times 17 is 68 plus 2, and then in the end, we end up with 70. So, therefore, the 17th picture is going to be 70 blocks. Okay? Now, other problems, okay? We might say that in using this algebraic expression, all right, n is equal to 3. All right, well, if n is equal to 3 and we need to solve using this expression, we're going to do the same thing. 4n plus 2, which is equal to plug in 3, 4 bracket 3 plus 2, and then we multiply 4 times 3, which gives us 4 groups of 3, or 3 groups of 4, which is 12 plus 2 equals 14. And we know that that was our third term in our sequence. Okay? Now, from this point on, we did a bunch of different things. So we turned this into a graph or a linear equation. Okay, and we made sure that our term number was along the bottom, and our term value was along the vertical axis. Okay, so term number 1, 2, 3, 4, and then value. Now this value might have to, in our case, we're skipping by 4, so maybe when we want to go, I don't know, we want to go 2, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. Now, on grid paper, it's a lot easier. Okay, so if we look at our table of values, we simply have the horizontal numbers here. 0, 1, 2, 3, 4, and we have 2, 6, 10, 14. These become coordinate pairs. So our first coordinate, right along the line, 0 and 2. This is where our line starts, right here. All right? And then we have our next term. Term 1 has a value of 6, so we might be kind of here-ish. If I have graph paper, it's more accurate. And then our second term is at 10, so it might be kind of here-ish. All right? Now, if I draw a line, okay, connecting these dots, okay, this should kind of go in one straight line. And if I continue, provided my dots are accurate, or my lines are accurate, all right, so I was at 14 for my third term, which is about here, okay? And then my fourth term was 18, which was 16, 18, right about here-ish, sorry. I mean, my line's not 100% accurate because I'm not using graph paper. Okay, so this is the line that is created by 4n plus 2. Okay, now the one key thing, notice because of this constant, it doesn't start at 0, 0. Patterns that start at 0, 0 have no constant, meaning that their 0 term is 0. Things like 2n, 4n, 3n, even half an n would start at 0 and work their way up from there. Okay? Anything with a constant is not going to start at the 0, 0. So I hope that this kind of goes through all of the key pieces of the puzzle and how we can find the algebraic expression using, find the algebraic expression from a pattern, a picture, a numerical list, okay, right here, a table of values right here, and then we can apply that to solving for expressions or plugging in term numbers for the n, and then graphing the information. It's simple mathematics. Check it out. I revolve around science.